All right, we're going to talk about piecewise functions. We talked about evaluating them yesterday. Today we're going to talk about how to graph them. And then the second two examples are what makes something a function as an equation, what can and can't happen. So guys, a piecewise function, all it is a bunch of graphs, but they don't want the whole graph, they just want a piece of it. So if you're given a question like this, all right, you have f of x equals x squared. That's a parabola. It's the drama. Yeah. You get x squared makes a parabola. If you don't know that, we'll make an xy chart. And then 2x plus 1 is a line. I know that 2x plus 1 is a line because x is raised to the first power. It's linear. All right, everybody understand that? This is what is super important right here. These are what's called your parameters or your boundary lines. That's telling you what part of the graph they actually want. So the way that you guys, the best way to do this is to graph each line or parabola or cubic function, whatever it is, graph them independently and then look at what you want to keep and what you don't want to keep. So what do I mean by that is the first one I'm going to do in red, x squared. All right, well, let's make a table of values for x squared. X and y. We'll plug in -2, -1, 0, 1, and 2. So if I plug in into x squared, if I plug in -2, what's -2 squared? +4. If I plug in -1, what's -1 squared? 1. If I plug in 0, what's 0 squared? 0. If I plug in 1, what's 1 squared? 1. If I plug in 2, what's 2 squared? 4. Okay. So if I was going to graph that, I have points at -2, 4, 1, 2, 3, 4. 1, 1, -1, 1, -1, 1, 0. Whoops. 1, 1, and 2, 4. All right, so if I connected these in a nice smooth curve, I would have something that looks like this. It's a parabola. Everybody agree with me? Okay? We all know how to graph lines and graph shapes and stuff like that. But what this is telling us is I don't want the entire graph. I only want where? What part of the graph do I want? Where the x values are what? Less than or equal to 1. So I'm going to draw a vertical line right here where x is 1. Guys, on the x-axis, right? Your x-axis is left and right. Where are all the values less than or equal to 1? To the left of that vertical line or to the right? Over here, aren't all of these values less than 1 on the x-axis? Yes, correct? So that means you want to keep all of this stuff over here. You want to keep this piece of your graph, but you don't want anything to the right of that line. So we would erase it. We'll go just like this, and you just erase it. So the only piece they want of that line or that graph is right here. And this is why this is a piecewise, because they just want pieces of graphs. They don't want the entire thing. Now, another thing you have to pay attention to is what does this sign say? Less than or equal to. So what kind of a dot should you have at the end of your graph right there? A close. Why is it closed? Because it includes this point right here. So now we're going to do the exact same thing. I'm going to change my color, and I'm going to use this line. This is y equals 2x plus 1. Well, this is a line. I know it's a line because it's x to the first power. You guys all know how to graph lines. You need the slope, and you need the y-intercept. What is the slope of this line? 2 over 1. And what is the y-intercept? Where does this cross the y-axis? At 1. Okay. Is this a positive line or a negative line? It's positive. It's going upwards. We know that. So get that in your mind. Think about it. So I'm going to come over here, and I'm going to do the exact same thing that I did with my parabola, but now I'm using a different color. I'm going to put an intercept at 1, and my slope was 2 over 1, right? So go up 2 over 1, up 2 over 1, up 2 over 1. down 2 over 1, down 2 over 1, down 2 over 1. Everybody with me? There's my line. So if I were to connect these, I'm going to just do a nice little dotted line here. Okay, we've all graphed lines before, so we're good. But now I have to look at the parameters. I have to look at, excuse me, I have to look at the boundary that they gave me. For that blue line that I just graphed, what are the values that I want to keep? What's the boundary line that I have to look left and right of? It says x is what? Greater than 1. So I'm going to draw another vertical line right here where x is greater than 1. Guys, where are the x values greater than 1? To the right of that yellow line or to the left? Everything over here, right? So that means I want to keep everything on that part of my line. And what do I do with the rest of it? I erase it. Good. So I would erase. And obviously this is easy for you guys to do on Notability. When you have a test or a quiz, you just might want to bring some colored pencils. Now there's one more thing we have to look at. One more thing we have to look at. What kind of a dot should I have right here? Why should it be open? Because this is not or equal to. It should be an open dot. Now, when you guys graph these, okay, however you need to do it, you guys need to do. If you need to write like this and say, hey, Mrs. Meadows, that's open and that's closed, you can do that if you want to. If you're not sure if I know or not. But you guys have to make sure that the ends of your graph are correct. If it goes on forever, you have to have arrows. If it should be included, it needs to be a colored in dot. If it's not included, it needs to be an open dot. That's very, very important. But do you guys see why this is a piecewise function? It's a piece of this function and a piece of this function. Whatever pieces you keep is all dependent upon what they tell you here with your parameters. Does that make sense? All right, let's do another one. Let's do the next one. We're going to do this one together. Okay, there's three. There's three different functions here. I have y equals negative 4x plus 3, y equals 1/2 minus 1, 1/2 x minus 1, and y equals 3. So let's just take each line. They're all lines, I know, because everything's the first power. So I'm going to take each line and use a different color. First one I'm going to do is negative 4x plus 3. Y equals negative 4x plus 3. Okay, identify what's the slope here. What's the slope? Negative 4 over 1, good. And what's the y-intercept? At 3. A negative line, guys, remind yourself, it's going to go downwards. Okay, so go over to 3. 1, 2, 3. My slope is down 4 over 1. So 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Right? Just kind of connect your dots. You're going to erase some stuff. So here's the important thing. You have to look at the boundary line. What boundary did they give you? Where am I looking? What do I want? All the values where what? Where x is what? Less than negative 1. So I'm going to go over here to negative 1, and I'm going to draw a vertical line. Where are the values on the x-axis less than negative 1? To the left-hand side or the right-hand side? What are these over here? Are these positive or negative, guys? They're negative. So are those the ones that are less than negative 1? Yes. So that means you want to keep everything to that side. You want to keep anything that's on that side. So I'm going to keep this stuff over here and do what with everything else? I'm going to erase it. So we just come here and we erase. Okay, good. Before I move on to the next piece, the next thing, what do I have to check for? What should be at the end of this line? Okay, we got to check our circle. Is it open or closed? Whoops, hold on. hard to do on explain everything. All right, so what kind of a dot do I have here? Why do you know this is going to be open? Because it's not or equal to. So you can go like this if you want. You can cross this off, make a big, huge circle. Make sure that I can tell that that is an open dot. It is not included. If you want to write the word open here just to make super sure that I see that, that's perfectly fine. Questions? All right, let's go to the next one. I'm going to use red. This line says 1/2 y equals 1/2 x minus 1. All right, simple enough. What is your slope? 1/2, right? What's your y-intercept? -1. I always like to draw a little picture. What kind of a line do I have here? Positive or negative? What is it? It's positive, right? So it's going to be going upwards. So I'm going to go to -1, which is right here. My slope is up 1/2. So up 1/2, up 1/2, down 1/2, down 1/2, right? Everybody with me? Okay, so now I'm going to look at my parameters. I'm going to look at my boundary lines. Where am I looking here? Between what? -1 and 3 on the x-axis. So here's where x is -1, and here's where x is 3. Guys, where is the x in this inequality? Where is the x? It's in the middle, right? So what part of my line do I want to keep? The stuff in the middle. I want all the stuff that's between those two values of where x is -1 and where x is +3. Now I can erase all the other stuff. I don't need it. I do not need it. We're good here. But what do I have to check before I just move on to the next piece? What do I need to check? I got to check the dots. What kind of a dot do I need on the left-hand side here where x is -1? An open, so I'm going to draw a big open dot. And then what kind of a dot do I need over here where x is 3? Closed. Good. So that's the piece of that line that I want. Now this next one is the easiest one of all, but it's the one that's the most confusing. Easiest one of all, but it's the one that's most confusing. F of x is a fancy way of saying what? Y, correct? So this last one says y equals 3. Huh? Think about what kind of a line that is. Where is y equals 3? It's right here, right? If I were to draw a line through that point, what kind of a line do I have? It's a horizontal line. Just a horizontal line. When you have y equals a number, guys, it's just a horizontal line. So now I look at my parameters. I look at where they're telling me to look on the x-axis, the values. What values do they want for this line? Anything that's what? Greater than or equal to 3. So I'm going to go over here to 3. I'm going to draw this line, my vertical line. Guys, looking on the x-axis, where are the values on the x-axis greater than or equal to 3? To the right of that green line or to the left? To the right. So that means that's the stuff I want. I want everything over here, and it goes on forever. Just going to leave it. What do I do with everything else? What do I do with everything else? You erase it. Good. And then the last thing you have to check is what? Is it a closed dot or an open dot? Why is it closed? Because it's greater than or equal to. Good. So I'm going to have a nice big closed dot there so I know. So do you guys see this is a piecewise function because you want pieces of this and pieces of that. It's very important to graph the line or the parabola, whatever they give you, and then draw your vertical boundary line where they're telling you I want values bigger than or less than. Less than means to the left of that vertical line that you draw. Greater than means to the right, and then you have to check if it's an open or closed circle. Does that make sense? Okay, 2 more things, we're done. All right, we talked about domain yesterday. There was 3 rules that you cannot break in domain. What was one of them? What are some rules for our domain?
That if the x on the denominator can't equal
Good, okay. If there is a variable in the denominator, you're going to have a domain restriction. What's another one?
Radical.
If there's a radical with a variable in it, good. And what's the third one?
Radical and denominator.
A radical
And
in the denominator. That's the third one. Everything else, everything's fine. It's all real numbers. So now we're going to it's like the same concept, but we're going to determine if something is a function or not. Because not every equation is a function. There's 3 different ways that we see functions. Actually 4. You can see it as a graph. But you can have a rule where you have a specific set of x and y values. You can have points where if I gave you like -3, 7, 4, 6, -3, 8, and 1, 2. And I had to say to you guys, is this a function, yes or no? What matters? What matters if it's a function or not? No x's, what? Can be repeated. So I'm just going to look just at my x values. If I'm given a list of points, the only thing that matters is my x values. Do you guys see a repeat in the x values? Yes, so then you would say, no, not a function. X cannot repeat. Y can repeat every single time. X cannot repeat. If you're given an equation, which is why I have this highlighted, there's specific rules. Y cannot be raised to an even power, not just any power, an even one, or y cannot be in an absolute value, okay? It's all dependent upon y. When you are determining if an equation is a function, y cannot be raised to an even power or an absolute value. You have a question that says, does the equation define y as a function of x? Yes or no questions, guys. There's 2 things that can't happen. Y can't be raised to an even, and y can't be an absolute value. So look at A. Is this a function, yes or no? What's the only letter that matters for us to look at? Y. Y. So circle your y. There's 2 rules. Y cannot be raised to an even power, is it? No. And y cannot be an absolute value, is it? So then yes, this is a function. All right, look at your y. 2 rules. Y can't be raised to an even power, is it? So then this is no.
So x doesn't matter. So it says no x can be repeated.
That's in its set of points. If I have, look at C. What's the letter that matters in an equation? Y. Is y raised to an even power? No. Is y an absolute value? No. So yes, this is a function. Okay, circle your y. Is y raised to an even power? Yes. So this is not a function. Look at E. Circle y. Is y raised to an even power? No. Is y an absolute value? Yes. So your answer here is no, not a function. Does that make sense? Those 2 rules. That's it.